All right, good morning, afternoon, good evening, wherever in the world you're joining from. Thank you for being here. This is the beginning of session 360 something of Tesos in Wi-Fi. 366, I think, because we had a 365 session last night with the Spanish-speaking guys. We had a CWNE wrap-up. We had the class. I happen to have some exam vouchers for CWNA. And we just put them on the wheel of names, raffled them with all the people that attended the Spanish-speaking class. And we got 5 happy winners of vouchers. Hey, those things are like $300 each. So we had some guys that won, and they're going to have to start studying because those vouchers for CWNA 109, they expire, I think, in November because the exam ends this year, right, Martin? And then they're going to have 110, the CWNA 110 starting September, and that's what's going to be what goes on for the next 3 years. All right, let me look at the chat in here. Today is Wednesday, August 5, 2026, and we have another class of the Wi-Fi design from Wireless LAN Professionals that we're bringing to you 100% free and like 98% in English. Go ahead, Martin. What do you have? What you got? Oh, wait, you're on mute. And I'm really bad reading lips, man. Walid, go ahead.
Yeah, talking about certifications, like I would like to check after we finish this course, what will be the difference, like if I would like to have the Hamina Network Architect, what will be like the additional or what more information I will get if I if I take the course for the Hamina Network Architect?
You just get a PDF, but
Okay, it's
the training, the one we're doing here, I would say is wider in knowledge because we don't have limitations in time and we're not just bound to the Hamina brand. Yes, we're learning about Hamina right now. And but this wireless LAN professional Wi-Fi design class covers all the tools. So the Hamina architect, you're just going to learn the same thing you're learning here. And it's all Hamina focused. Right now we're focused on Hamina, but will be focusing on Cedos systems later,
yeah.
and then we'll do Wavelify later, and then we'll do Ekahau later, and then all the CWNA part we already cover. I don't know how many hours of training we've had on just regular CWNA. We've had multiple sessions. The Wi-Fi things.com is where we upload all the videos, and in there, if you scroll the way down to the bottom, those are going to be, this is the first class we had on IEEE. We spent, let's see, how long is this video? An hour and a half just there covering that. And then another hour and a half talking about RF amplitude frequency antennas. And then we spent another 2 hours or so talking about NICs, network interface controllers. Let me see, let me go back to my newer posts. And then basically that has 1 day of those basics and fundamentals. We probably spend more than that in here because we don't have the time constraint. We don't have that. We have to finish this today because tomorrow we have something else. And everything is going to be here, going to be recorded. It's just that with our class right now, you don't get a PDF with a certificate of completion. We do have a wireless LAN professional Wi-Fi design class, and we can do it with, we've done several. I've done, and people will get certificates from wireless LAN professional. That will be a certificate of training. So we have a wireless LAN professionals Wi-Fi design with emphasis in Cedos. We've done several of those in Latin America, here in the US. We have the WLANPros Wi-Fi design class with emphasis in Hamina. We do have the general one. I've done classes for companies that they needed all 3 of them because they had Ekahau. They needed to train people in Ekahau, and they were acquiring Hamina. And then they wanted to know about Cedos, so we created that class to just give people access to all the tools, not just bound to one. And then in here, what this does is that it gives you all the knowledge. We're covering everything just because we are offering a free class doesn't mean that it's limited and, hey, if you pay me, I'll give you the rest. No, we're giving you everything in here. So all the knowledge is here. Yesterday we had Jerry from Hamina. He came and answered some questions.
Yeah.
Oh, and by the way, he replied about this lab only thing. Let me see if I have this guy in here. Let me close. The thing about slab, remember that we didn't know what the attenuation was? It was if you only, let me just bring this guy over here. This window's too big. Okay, if we go to slope floors, it's actually raised floor. Yeah, slab only. If you choose slab only, because what we're talking about, for those of you who haven't been here, is when we add the attenuation to the floor, when you create the building, you add attenuation for the thickness of the floor in here, okay? The slab, in this case, when you add this slab, then let me just show you the options. If in here you mark slab only, then the attenuation is the attenuation of the overall floor. See, when you remove that one, you can specify what that slab, because you might have some areas that, yes, the floor is certain thickness and certain attenuation, but you might have stairs or you might have other areas that has a different attenuation index. So you can come and specify what it is. If it's maybe just a 5 dB per meter, or if it is actually thicker, then you can specify that here. But if you do slab only, see, you don't have that option to specify the attenuation, then it inherits the attenuation of the floor, which you specify when you create the building. See, I went here to this option below the walls, and then align floors. That's when you create the building, and then you can drag and put more floors in here. Then you specify if there are floors with more or less attenuation than the other ones, okay? One thing that they don't have here that you can set in Ekahau is the thickness of the actual floor, okay? Because there are floors that are thicker, some others are thinner, so you can specify that in Ekahau. Martin, go ahead, unmute. We're gonna talk to us about CWNA.
Well, I put it in the chat.
Oh, you put it on the chat. All right.
Yep. We can send it to the lucky winners yesterday.
All right. Let me just put this in here. There, put the chat window to the side. Okay. Expired CWNA vouchers may be exchanged if not used before December 2026 for the 110 version. If you kindly ask the CWNA support team, they are great in that. Thank you very much. Gurpreet.
Just a question for Nick.
Yes.
Just wanted to get your expert opinion on this one. So normally, yesterday we were doing the tables and stuff like that. Now,
yeah,
do you see value in that? Because generally it takes a lot of time. And the reason I'm thinking this is because most people, when they're using a laptop, that's probably sitting on the table and then the AP is above it anyways. Does it even come into the play as per your...
So when you are doing just one floor, the height, let me just come over here. If I am doing, let me just show one floor only. There we go. If we are, what he's asking is, this takes a long time to draw all the walls and doors. And then on top of that, if you're going to start drawing like tables like this, or you just draw something, is it worth it? Because here's what happens. We have an access point. The access point is sending waves, double the distance. Hamina is just doing math, and then it attenuates going through that wall and attenuates going through this glass. And then by the time the waves get to the top of this table, if you have next 65 in here, that signal prediction, you just switch this guy. Actually, let's move that access point here. If I bring that access point, and let's say I place it in this conference room right there, the signal prediction, if I have my mouse over here, notice on the lower left corner, watch this guy that is green. As I move the mouse, there is a slider bar that changes the value. This value says neg 48, neg 46, neg 44. Right on top of the computer says neg 50. So this signal prediction, by default, see if I come to the global settings, by default is at 1 meter from the ground. Ekahau does the same thing.
Yeah.
By default, if you don't specify the height of the signal prediction, it stops at 1 meter from the ground. Now, why 1 meter? Because the top of the table is normally at 90 centimeters from the ground. Okay, so you do signal prediction, double the distance, square the power, then signal power. Then what is the signal here on top? But what if you want to know what the signal is at ground level? I went to schools that I walk in there. I was doing the analysis, and then there were no chairs, there were no tables. And I asked the teacher, like, "Oh, are you guys like cleaning or remodeling or no?" They said, "Oh, no. Here we're against the policy of having children sitting strapped on a chair and a table all day. So we let them roam free." And they had like, bean bags, and they had all kinds of stuff just laying around for kids to just be whatever. So what is the signal at ground level? Or if you happen, because, we always think a client is a human holding a device, a computer, or holding a tablet. No, a client can be a robot. See, we had in the first part of the class, when we talked about the clients, the client can be a truck. The client can be a robot. Let me see, where's my stuff here? WLANPro. This will work. Okay, let me open this guy real quick and just remind you of what clients can be. Because when we're talking about clients, where are the clients? Let's see, clients. So it can be sitting on chairs. The APs are under the seats. We did this here at the University of Utah Stadium because we did the survey when there was nobody around, and then it covered the entire thing. And then it is different when it's crowded with people. This is at the Sphere in Las Vegas. The access points are in boxes under the seats. Clients can be inside a metal box moving around if it's a hospital and they have these metal enclosures. So the client is going to have a hard time sending and receiving waves inside those metal boxes. So in this case, I will have to look at, just a little bit above 1 meter from the ground. In this case, the signal prediction, see in here, the antennas are up high. That's like 2 meters from the ground, okay? The clients may be down at ground level. So it's 10 centimeters from the ground. The antennas on these robots are inside. They ended up putting the APs down low. So for that reason, you can change the height of the signal prediction. By default is 1 meter. So the question is it even worth spending all that time drawing all those tables? Well, let me tell you where it's valuable. If you're just one floor, and then everybody has tables and the devices they're going to be using are at height of the table, then it doesn't really matter if you put a table or a block or you put nothing or you put whatever you put under, it's irrelevant because the signal that you're trying to predict is at 1 meter of the ground. But if you have multiple floors, okay, let me just go to a 3D view. And right now I'm on the first floor. But what if then I have multiple floors? If I have an access point here, okay, the signal prediction for this guy, let me make sure that I do have selected Wi-Fi. Yeah. The signal prediction for this guy then is going to be not only on this floor, but it's going to show how much of those signals bleed to the floor below. So let me just go back to floor 3. See, if I have this guy selected, and let me for now just hide the attenuation areas. So we don't have the ceiling because we learned yesterday how to draw a ceiling. If I have this AP selected, in this floor, the signal prediction is horizontal at 1 meter off the ground. If I go to the floor below, so if I go to the floor below, I'm gonna have, notice these access points. The access point on this floor is this guy. Let me delete it, okay? I deleted the guy from this floor. So basically this floor does not have any access points. Notice in here, there is a grayed out access point, but it has an arrow pointing up, meaning these signals are coming from the access point from the floor above. And also these signals, see these signals over here in this conference room, they are coming from an access point that is on the floor below. I don't have any APs in this floor, see, but this one is bleed. So in that case, Gurpreet, having tables and stuff matters because watch, if I go to this access point on the floor above, notice how much, let me just move actually that guy. Let me go over to floor 3 and let me move this guy, let's say over here. I just actually put it like right on top of this guy. So if I go to the second floor, to the floor below, and let me actually go to the first floor and move that AP out of the way so we have a clearer view. Let's just put this guy on this very back corner over here for now. Okay, so let me go to the second floor. So it shows that these signals are bleeding from an access point on the floor above. That's also taking into account the thickness of the floor. Watch what happens if I say like, oh, the floor on the third floor is not 20 dB, it's only 10 dB per meter attenuation, you know, thinner floor. So if let's just go back to my signal prediction, notice how much more signals from that AP bleed down. Now watch this. If I go to the third floor, see, because right now under that AP, let me look at attenuation objects. And here's what I'm gonna do. I'm just gonna move that ceiling out of the way. Let me click on this guy, just delete it. I got rid of the ceiling. So I have a table. If I don't have a table here, see, I just deleted the table. Why I didn't delete the other 3 legs? Let me move this AP to the side. Let me delete these legs and put the access point there again. Watch this. If I go to floor 2, I have more signals bleeding down now because I don't have a table over there. So when you have multiple floors, Hamina is not just doing signal prediction horizontally. It's also doing vertical signal prediction and takes into account not only the thickness of the floor, but also tables, racks. Look, if I add another attenuation object, let's just add column, chair. Where's the warehouse rack? Shelf warehouse. Let's do this warehouse, a shelf. And let's just add one in here. Okay. I'm on the second floor. Let me go to the third floor. Let me add one of those guys over here. Okay. So now if I go and edit this guy, let's change the height not to be too dramatic. It's not 8 meters. Just say this is just 1.2 meters in height. Okay. So if I go to 3D, I just added those 2 racks or shelves in there. Let me go to the second floor. Okay, floor 2, right there. Go to 2D and delete this guy. Delete this guy. Let me just come to the arrow. Delete this guy. Delete this guy. Come on. There you go. So now, remember it was like really green before when I had nothing? Now that I added that guy, so the AP sends waves, double the distance, quarter the power. It hits that, it attenuates, then it hits the floor. Those waves get weaker. And by the time it hits this floor, it's not very strong. So yes, right now, adding attenuation areas matter. Okay. Because I'm looking at the bleed. And sometimes we want to make sure that if something bleeds down, then maybe relocate APs, because we have to keep that in mind. You don't want to have it like, oh, look, this room has coverage from the floor above. Don't rely on APs from other floors as your source of coverage or secondary coverage. Those are things we have to keep in mind, because now if you remove this guy, go ahead. If you remove this guy, or let's just move the access point to the room next door. See, if I move this guy over to this table and go back to 3D, then it has like more signals bleeding down, because I change with the attenuation of the stuff. It's just that in real life, see here, I can change the thickness of the floor or reduce it. In real life, you cannot just go tell the customer like, yeah, you know, that AP from the floor above is bleeding too much down here. I recommend that you add another layer to the floor. Like, that's not going to happen. You're not going to add another layer to reduce attenuation. Then you have to start playing with power, location of access points and stuff. Go ahead. Somebody had something.
Yeah, me. So the way I deal with this is I don't, but I'm mostly working on offices, not more complex environments. The way I deal with this is I'll leave this for the post survey. So with the real measurements, then I can select all the access points in a floor and go to upper and below floor and check how much signal is bleeding to these channels. But I think for predictive, sometimes it could be too much work. Depends how precise the environment will require from you.
It is way too much work. And that's why, I mean, I never draw something like this with a table with legs. You're kidding me? I would never do that. We did that in here just to show, you know, how to do it if you really have the time. But yeah, I mean, it looks good, but in reality, you just don't have time to do all this stuff.
See,
Check
another
what
thing,
I did in the chat window later.
So just one other thing, Ferney. So, you know, I think how Alex mentioned, you can do an AP on a stick. You can understand the bleed through between the floors. That's something measurable. You can add it on. But you remember how you were showing yesterday, like the duct, for example, or even at the Enna Care Center, you had that big round thing in the middle of the floor. How do you find the real, you know, measurement of that device or that object that's hanging in the middle of the air? Is there any way that you've figured out the way to kind of understand
well, over there, when they had the things on the ground before they moved them up, I could measure the attenuation of that. But once they're up, it's really hard to measure. The one thing you can do is try to, with the access point, just try to avoid those locations altogether. Because the problem is when you end up with those access points and then they put stuff underneath. Christmas decorations. Now at a shopping mall, they have the access point. It's all empty, but then Christmas comes, then they put a fat Santa with a sleigh and deer hanging from the ceiling as decoration. Now that guy's on the way. See, then you have to simulate those and getting the attenuation of those things. Like, how are you going to get up and measure that? So you just try to avoid those altogether. And some of those are hollow, some of those are foam, but some of those are wood, or some of those are just screens that are just metal structures or trusses with speakers, because those are one of the things we're saying. That's just solid metal with electronics. Try to avoid those altogether and put the APs, as I did over there, below those structures. I drew him more to like show the customer, like, look, that's where the lights are. We have to avoid that, the screens. And then I drew a screen, because then we had issues with the AP was like in front of the screen. So we had to move those APs up and then move them out of the way. And in that case, you just draw that mostly to show customers real environment on the 3D design, so it is easier to explain where things go, where things should be, and how low the APs want to hang. But the reality is you want to bring the APs as close to the customers as possible. Walid, what do you have?
Hi. So also, like, in addition to attenuation, I believe also like sometimes in some sensitive designs, like drawing tips tables or obstacles like that may also like affect on the wave behavior itself, like like the scattering, the reflection, refraction. So I think like I didn't have a chance to compare between a predictive site survey and like on-site site survey with Hamina. But from I believe also like the time like I could save in drawing the walls and drawing the building in Hamina comparing to like IKEA, for example. Like I could save that time to drawing like the real like infrastructure, like the
Uh-huh.
tables,
Well,
everything
Walid,
else.
now you mentioned that, let me show you my absolute best and favorite feature. Good morning. Tom is
Morning, sir.
early. So California. Okay. All right, Walid. Watch this, man. Watch this. Guys, this is my absolute best and favorite feature from Hamina. Ekahau doesn't do it. Cedos doesn't do it. Wavelify doesn't do it. Hamina does. This is a predictive design. See this? Let's say I go on 3D. Nothing here we haven't done. Well, like putting colors on the APs, that's something we haven't done. I'll show you how to do that today. So it's a predictive design. There are walls and doors drawn, access points placed. I did a survey of this facility, okay?
Mhm.
Access points were placed, and then here's the story behind it. See, it is all green everywhere, well, most everywhere.
Yep.
That's what we proposed. The customer said like, no, that's way too many APs. Let's remove that AP. So we said, okay, but you're going to need it. No. The AP from this room will cover that one, and the one from this room will cover that. We'll remove this AP. Okay. So I left the AP there, but then we made it red so that I can highlight which APs the customer decided to remove. And then they left these APs. They removed these APs, because they assumed that this AP would cover that area, that this AP would cover that area, that they didn't need those. This is a senior care facility where they take care of older people. I go and do a survey. I almost got arrested on this site too. Man, I've had my run-ins with the law in a few places. First, I got arrested in Germany. Now I almost got arrested here. See, if you don't believe me, let me show. Man, that was kind of scary. Because I go do a picture. That place was ready. They said like, yeah, go and do a survey. The place is finished. The place is ready. That was in upstate New York. That was actually not upstate, but it was about here, I believe. Let's see. Yes. They said the place is ready to do a survey. They're done.
Almost ready.
Almost ready. So
Yeah.
I go there. There's a big facility, multiple floors, and then I start doing my survey. And I ask the guys, like, how late can I stay? Because this is pretty big. I'm not gonna have time. And I was fixing cables and stuff, multiple floors. I can stay as late as you want. I go there, and when I leave at night, the gate was closed. So I leave the car there. I'm small enough that there was a gap on the gates that I could go out, and I ordered an Uber. And while I was waiting for the Uber, cops showed up, like front. Here, where's my stuff? Cops showed up on the front and on the back of the property, like coming from the building. And like, I mean, look at the amount of cops. Like I had like 3 cars on the front, 2 of them, and 2 on the back. Lights on my face, hands where I can see him. What are you doing there? It was like 10 at night. What's the time? 10:35. And I could explain what I was doing, right? But here's what happens. I go to a facility, do a survey, and watch. Eyes on the screen. I switch from design to survey, and it just shows me what the attenuation of objects and walls was. Again, simulation, same project, okay? I didn't have to create I just say, I open that on my phone. We'll get to surveys later in this class. And then I go in and do a survey. See, in here, there are no walls. It's just my walking path, So now I can use this, and this is what the other guys don't do. That watch, if I, let's say, move this to 3D, let me go to simulation and move it to 3D. All of you can do this. Now you know how to draw walls. Now we're going to learn how to do the APs and move them around. This is the predictive design we present to the customer. See, and if I zoom in and I move things around, zoom out, and if I go to 2D, see, that's the area. 3D, that's the area. And I can switch from simulation and survey. My map stays right where I left it, which is really great because then I can show a customer, see where it's read that the signals are not very good. Yeah, that's what we recommended in the simulation, that you'd have APs, but you decided to remove them. So here, this is basically what you use as a warranty, or the, see, I told you so, just to show like, look, but yes.
Did you measure the wall on your predictive in order to get the right dB?
Not on the predictive on site, because when we got the floor plans, the place did not exist. They were building it. So we couldn't go in there and measure, but then based on the floor plans they gave us, we used those values with estimated values, if they were brick or if they were drywall. So if I go to 2D, I can see that these areas, they had brick. Okay. Is that brick or is that like heavy? Let's see, drywall 4 dB. So thicker. Well, this stuff is concrete. See this stuff? That's concrete, 15 dB. Right. Because the floor plans, they are going to have, see, if I say, don't show me walls, see, they have, and Hamina is going to have this, that it identifies that in the drawings, this is a thicker, either brick, cinder block, or it is concrete. So those are concrete. These ones are drywall. If I say, show me walls, see the difference?
Yeah.
So that's what we use. And then when you go on site, now watch this. All I do is walk, click, walk, click, walk, click. And some people say like, oh, Fernand, you know why you spend so much time in the bathrooms? Yes, I go and survey every bathroom, especially in this place, because this is a senior care facility. Where do older people usually fall and break their hips? In the bathroom.
Yeah.
So I want to make sure, and not only I go and survey in there, I go in, close the door, and then survey and get the signals, get the readings from that place inside the bathroom. Because if the older people are wearing I don't know, a bracelet or a necklace piece that they can just press a button and call emergency in case they fall, then if that's with wireless, with Wi-Fi, then I want to make sure that there is good Wi-Fi there. So that's why it takes time to do a good survey, because I go and walk every corner of every room, including bathrooms, to get enough readings. And this, what I measure in here, that's measured. Here's the best part. Watch. If I want to design, see, if I go to my simulation and I come down here where the readings are, since I already went on site, okay, when I am doing my design, I can also use data learned from the survey. Ekahau does this, and they've done it for a while, and I love that. If you go and do a survey, you can use this data to do your design on top of the survey, because then you can say, like, if I was here and I have an access point, let's say I select this access point, okay? This is measured, okay? If I am there, the signal's pretty good. Next door, it's okay. It's good, but it's not like as good as in here. Same in here, and in here where it's yellow, it's like next 69. See the lower left corner where it shows you what the signal is? As I move the mouse, that little slider bars are like, right here, the signal is next 56. I'm closer to a wall. Here, next 69. Here, next 71. So this is accurate because it's measured. I was there. So if I was here and I measure you, let's say a neg 45, and then here I measure you a neg 47, then it's going to start using the attenuation that I saw, that I measured from one side to another. And let me just hide the walls here for a second. Let me not see any walls. Let me come over to my simulation and let's tell this guy to not show me the walls. Come on, 2D. I gotta go to 2D. Let's tell this guy to not show me the walls. Okay. So what it's doing in the design, if I'm gonna use survey data, is it uses what I measured here and what I measured there and assume extrapolate the data. If I saw you here at neck 45 and I saw you there at neck 47, it's gonna say like, well, this is probably a 2 dB wall. So it's gonna use survey data for your design. And you don't have to draw walls. In that case, you'll just place access points. Ekahau does that. Hamina does that. And I think Tesos uses AI also in your designs. When we get to Tesos, we'll talk about it. But that's one of the advantages of being able to go on site. Not always you can go on site. Go ahead, Alan.
Yeah. Do you have a dB offset on Hamina like you do on Ekahau?
Okay, so the offset here is the same, but it's called and shown differently. Let me show you that.
Okay.
Also down here, okay, down here in this area, the settings. This is what type of signals I want to see, primary or secondary coverage, what band. Let's just pick 5 gig. If I go to the global settings, here is where we can set the opacity of the signal prediction, like very clear or just very dark, so that I can almost cover the map beneath me. See, this is the first setting. So I like to have it like here in between. I want to see the signal, but I also want to see what's there. Oh, that's the bathroom. See, because if I have it this strong, I don't know what's underneath.
Yeah.
The next setting is going to be client height. That's what we talk about it. By default, it's at 1 meter. But what if I want to know what the signal is at ground level? Okay. Like, what is the signal? Not at 1 meter off the ground, but how about lower than that? Because I want to make sure that, for instance, is the bathrooms, if I want to see what the signal is at 10 centimeters from the ground. In case a person falls, am I going to have enough signals at ground level or higher? See, because when we were looking at the warehouses, if my antennas are at 2 meters, where are the signals going to be at 2 meters from the ground? Then down here, AP shown on mouse over is this. If I like put my mouse in here, notice to the left, there is a list of the access points I see there. We got Hamina to fix this for our survey in Toronto. This is new because before it showed like if I saw 80 APs, it showed 80 APs, but it showed me like the bottom of them. So I could see like the bottom 40, the weaker ones, like, no, I want to see the top 10. So they changed this for us just 2 weeks ago. That if I come over here on mouse over, global settings, on mouse over, I can say like, no, just show me the top 8 APs or the top 3 APs. Below, there's going to be, so that's the client height. In here, see that little man right there, Elaine?
Yeah, I do.
That's the client view, okay? That's basically what we call in Ekahau offset. What does the client view? Which client? See, there's a list of stuff here for Wi-Fi. Let's say a phone, an Android phone, a MacBook, an iPad. So if I say, no, what would a Android phone see? Let me just go over, make sure that we do have. Make sure. See a little guy right there? Once I click on it, this is what that little man, that client, that Android phone would see in this area from that AP. This is just doing kind of like the offset, but it's just being doing a more realistic, well, realistic and not because it's simulated still, but it's just doing math, saying like, okay, from that AP, if I am the client and as I'm walking, which is my strongest AP in this area, which is my strongest.
But, Fernie, you're under simulation now. When you do it on Ekahau, you would be under survey with measure stuff from your Sidekick too. Right?
And then in here, if I do the survey explorer, what it does, it shows what I measured that day with whatever device is it that I was using. In here, let me see if there is a way to set offset on the. I think Hamina believes that offsets are not required in here. But
No,
let me
that's
see.
sorry to interrupt, but that's what I was really wondering about, because I made yesterday a simulation I made in Hamina again in Ekahau, just to compare, just because I indeed recently heard them say, well, we don't believe in offsets. We believe that minus 65 should be minus 65, whether you're in simulation, whether you're in a measured. You shouldn't be worried about that. Your software should just always say minus 65 is minus 65. Good news, the simulations look identical. So that means that the math is indeed the same. But it also means that minus 65 simulated on Hamina is the same as minus 65 simulated in Ekahau. And if you measure with the Sidekick, obviously that minus 65 will not be the same as the minus 65 you've come from just the free space pod loss. So that makes me really wonder how they treat this, if they indeed alter the measurement from the Nomad or the clip to represent the minus 65 from the simulation. Or if they just haven't done that completely yet.
And the reality is that they try to make those devices as accurate and tested in an environment to make sure that it measures what's in the air, but it's impossible to have a device.
You can't measure free space pod loss. You always have the receiving end, so
absolutely. And you have the devices like the software, Ekahau and Hamina, doing math. And that's why they're identical, because they have an AP with certain radiation pattern at a certain height, at certain power levels, sending waves. And the math is the math, double distance squared the power. And then at 1 meter of the ground, this is what should be in the air. Whether or not you're measuring that with an Android phone, with a computer, or with an iPhone being held like this or being held like that or flat on the table, it's going to change. And it may change just 2 or 3 dBs. And you may say, it's only 3 dBs. That's half or that's double the signal that you are getting. And when we get to surveys, we'll see. And Lane, or you guys that have been in class with me, we did tests and we measure stuff, and every device will see different things. As a matter of fact, like some of the testing I did with the Ekahau Sidekick, measuring a football field, same place, same height, same speed, same everything. All of the heat maps were different based on how I was walking. If I was going north-south, I got one heat map. If I was going east-west, I got a different heat map. It's just nearly impossible to get a repeatable heat map.
I tried roughly doing the same thing, but then to make a comparison between the simulation and then the Sidekick measurements to try to make a kind of offset between, say, free space pod loss and then the receiver end of the Sidekick. But there's such a big difference in measuring in, say, a football field where you're completely open and just your street, which is also kind of open, whereby you do have some houses and cars parked with some reflections, which already alters this factor so much that it's really impossible to really come to an accurate not really an accurate measurement, but to say, well, this is like roughly the offset for every situation. It just differs so much that it's quite hard to just say, oh, let's just compensate, say, the measurement with 5 dB, and that's what we should see in the simulation, or vice versa. So that's
And that's why I ended up going to the salt flats and just playing with Wi-Fi and things over there for what you just described. Happened that I was doing surveys in a football field. Right, this guy. And I came across a phenomenon that didn't make sense. I went to a football field because it's open. There's nothing. And here's the access point. The way we did, we set up one of these trusses with access points in one corner of the end zone. And then it's an access point at certain height sending waves. It's open space. Free space pod loss is double the distance, quarter the power. as I went away from the access point, the signals got weaker and weaker and weaker. And that makes sense, right? But then it got to a point that it got so weak that it was great. It was like neg 70. And then following the laws of physics, those waves keep getting weaker. But in here, they got stronger as I got further away. And I was confused, like, but why is this signal from this AP strong and weak, gets weaker as it goes away, and then it gets stronger? Well, it happened that in these football fields, there are bleachers. There are metal structures out there, which is what Glenn just described. There are going to be reflections, okay? There are going to be reflections, and then those waves will bounce, and then you're going to see them in different places stronger. And this is what I was telling you about, that depending on how I was walking, because that's why I ended up in the salt flats. See, I went where a place where there were no trees, no houses, no buildings, no bleachers, no nothing nearby, okay? Because I was trying to test the speed. This is walking. Those are the heat map I got and the distance I walked and how long it took me. This is on a Segway. This is on a car. Got on a car, and then, yeah, going faster, then you collect less data points, less samples. But then my confusion was, if this is all open space, actually speed seems to matter based on the number of channels you're scanning and such. But then in the design, when you place this in Ekahau, see? So like, oh, it's a football field. There's nothing in there. And it just shows you that this is what I should see. But this makes sense? This is design. This is predictive design. So I started surveying, doing continuous. And here's when I realized that going in that direction, I got one reading. Coming back, 5-yard line, it was bad. And then over there, it was good. And then coming, it was bad because my muscular body was blocking the psychic. I had the psychic on the side. And as I was walking, depending on how Mark said, depending on which direction your body is facing and how the psychic was facing. So I was covering, and then I was getting different signals. And I know this is design. We ended up talking about this, but these are concepts we have to cover, okay? Because the client offset and the signal prediction is one thing, okay? It says if you place the access point there, it's free space, and this is what you should see. But this is what I was seeing. Because why I ended up doing is so that I did not block my psychic with my body, I put it in my head and say, okay, if I don't block it with my body, how is this going to look? And it looked different. And I said, okay, what if I put the psychic up above in the way that I carry it vertically, but then above me so that I'm not blocking it in any direction? And then I started surveying, and this is what I got. This is the heat map going east-west. This is the same survey, same AP, same height, same device, same speed, same everything, but going north-south. And here's a more shocking revelation. This is what design should show us, that that's what the coverage should be. This is the heat map I got going north-south, going north-south the other direction, going east-west. So which one of these heat maps are you going to show your customer? Because design said that, hey, you place this access point here, it's going to cover this much at that power level, at that height, at that, with that radiation pattern. And then based on how you survey, then this is what you see. That's 2.4. This is in 5 gig. So which one is accurate?
They all are, but with the note that it is as it is measured, which is why
Absolutely.
I personally do always both of them, which takes a lot of time. So if you go into a room, I always do that room in both directions.
Absolutely.
If you have the aisles in a warehouse, I walk them both directions. But it also means that you have to look at these results in more detail, because as you can see in the one where you have the going left, right, where you go one way and then come back, there is a difference between both, and you have to treat them separately, because that sometimes shows you then that it seems less than the other side, but it really shows you useful data, but it messes up a little bit, say, the green picture for the customer. So it requires more explanation to the customer then to understand what they're seeing.
You do two separate surveys, not one survey, not walking in both directions on the same survey.
On the same survey.
On the same.
See, on the same survey, you walk each room twice.
Right.
Especially the rule is just walk both sides of what you care about, and the more data you collect, the better. Now, this is not just an Ekahau thing, okay? No. Don't think I'm picking on Ekahau. This is just, I guess, an RF thing, because this is, I have a building in Colombia, and I have a gym where I placed a Ruckus access point, one of those with the directional antennas, on the window shooting down the street, okay, in that direction. My friend Diego was walking. So here's the access point aiming in that direction, okay? We start walking away from the access point, and it looks bad, like all the way, because he's wearing the Nomad in front of his body, and the AP is behind him. When we go on the other side of the street, this is open space, this is free space. And then now we're walking towards the gym, towards the building. On the other side of the street, it looks good all the way, because the Nomad is always direct line of sight to the AP, it's facing the AP, so it looks good. So is this bad or is it good? Is this what we measured that day with the APs in the position where it was and the measuring device in the position that we were carrying it? Martin.
Yeah, I asked Jerry a couple of years ago which value are actually used when creating the heat maps, and he couldn't really get a good answer. I was saying, is it Ekahau using the best value it was recorded, depending on the best value will be when you're going towards the AP, or it does take an average of the worst and the best, and he wasn't sure. So that's another factor that we don't know really which one is used of those measurement points.
And it just gets an average of all these things.
I'm not sure that they do.
In some cases, I think they do. And the more data you collect, because he's doing interpolation of the data in between the measure points.
You can see that quite clearly if you move to the point view. So in AI Pro, if you don't go for the rounded visualizations and you just go for the measured points, then you can clearly see that you might even have a gray point next to a green point. And then if you take those values and the value that you really see in the interpolated result, that's really kind of the average of the measured points. But in general, that then tends towards the better side and hiding a little bit of the worst places. So I even have a case in a marine ship where that leads to showing you that there's still coverage in one of the cabins, but if you look at the points, then there's absolutely no coverage at all in that area.
Yes.
I was walking exactly along the same line. I was not doing like 2 meters apart or something like that. Back and forth, exact in the same line.
Same line.
All right, and we'll cover the survey portion later. Now let's finish what we started. I mean, this is a great conversation. See, that's the advantage in here, is that we have like, guys, we have to hurry because we gotta finish class. Like, no, let's take our time. If we don't get to placing APs today, guess what? We'll do it tomorrow. It's okay. We're in no hurry. But then this explains how better to design. We're talking about, do we then go and measure the walls? Well, if you can go on site and measure the walls, sure. But if when you were designing, the building didn't exist, there's no place to go measure. Even if I go now, what's the problem with doing the survey now? You have all this stuff along the way. So maybe if the access point, wherever it is, and I'm on the other side, maybe on the map, it's going to look like this is a bad spot. Yeah, because you had like tons of stuff that is not going to be there in real life. Once they clean this up, this is not going to be an obstacle for those waves coming from the AP. So those are things that have to be considered. But I cannot show up on site, fly all the way from Utah to New York, rent a car, drive up there, and then say like, oh yeah, this is not ready. I'm going to come back later. Like, no, I'm there. I have to go. And as a matter of fact, I spend part of my day re-terminating cables because they had, just terminated them wrong. Some of them, not all of them. There were just a couple, but when you're on site and you don't have the tools, 4 cables become a 2-hour project, trying to re-terminate them, trying to find the tools, trying to get somebody to help with a ladder, with, getting up there. So carrying all the tools all the time is going to help. And this is the problem. You do a survey and you're going to have all these obstacles that you're not going to have once the place is finished. Okay.
Hey, Fernay.
Yeah.
On that senior care facility, did you have a client device in mind that you started the design with? And then the second question is, in Hamina, can you actually, after you do your survey, see your client roaming to the different access points in real time? If that makes sense.
Okay. Yes and no. Let me just start with the first question. Yes, when you're designing, you start with a client in mind. And here's what the thing with the offsets that we were talking about. Ekahau calls them offsets. Here they claim the client experience or the client device. This is basically, if I have this access point selected, the signals predictions that I see right now, they're just raw RF. This is what should be in the air from that AP. Watch this. That AP with these antenna patterns at that height, at 3 meters, at these power levels. Those APs at that height with those radiation panels, with these walls around them, it sends waves, double the distance, quarter the power, and then the colors just represent a value in dBms. This is what should be in the air. If I go to the client view and say like, no, the client that I have in mind is a Wi-Fi client, and let's say here they're going to use an Android phone as the client. So what is this client, if I place it over here, gonna see from that AP? Notice that right there, it's like it's a neg 80. And then you just gonna come and say like, here's neg 69, neg 70, neg 71. This is doing signal prediction. And it is subtracting. I don't know, let's just pick a spot in here because I don't have an easy way to compare the two. Let me see, interference, APs, neg 59. Say that right here on this corner is between neg 58, neg 59. If I switch to just the regular one, right here, it says neg 54. See, same corner, same place as where I had the little man standing. So this is what should be in the air, neg 54. If I switch that to a client view, it says it should be neg 58. So it is making it like 4 dB weaker. It's an offset. That's what Ekahau calls an offset.
But here it says 5 gig, and in the signal strength, it's at 2.4. So does this also only work on 5 gig?
Let me switch it back to 5 gig. Then let me switch this to 5 gig. And let's just go back to here. Next 60. Go back to this guy. Next 58. So this is what an iPhone or an Android phone would see. Which, again, this is, I don't know, just applying it. Because how is the phone being held? At what height? Yeah. We've done testing that if you have the phone vertically with this hand, you see one thing. You have in the same position, same orientation with the other hand, you see something different. If you just move it a little bit, it changes. You get closer to your body. If you put it sideways, if you put it flat, if you put it flat on top of the table, then it sees different things all the time.
But in that project, though, did you have a device in mind when you started the design, meaning like the Voicera phone? Did you have one of the little pendants in mind, or was it just a more generic design when you started?
It was more generic, and we try to make it aggressive that we go to neg 65 And in some places, you just go to Next 62 and you design for Next 62, trying to give, like, if I have Next 62 in the air and these devices are 3 or 4 or 5 dB less than when other devices will get, or the sensitivity is less, then you kind of compensate that way. So there is also the attenuation areas. In here, we just have walls. But then in real life, they're going to be desks. They're going to be filing cabinets. They're going to be other stuff that is not accounted for. That's why when you go on site and do a survey, you're trying to get a more accurate measurement of the real life environment. But as you could see on that site, it was not like as close to reality because the site was still under construction. And there were still a lot of obstacles in there that I would not have once the job is finished. So it is so relative. And it so depends on what are we trying to prove. The design, you start, and in many places, most of the time, you don't get access to a building to go and double check and measure. If it's being built, all you have is a floor plan. And they said, I need to know how many APs and where I place them. And that's when we go to these sites. Let me just go to Bramer stuff. That's why when we do the simulation in these sites, you just go with your instinct and then just add what these guys have added to the library of materials. They have tested, okay? The thing is that when we're talking about a brick wall, is it bricks made in Sweden or is it bricks constructed in the Dominican Republic or South Africa? Because the clay is different, the construction is different, the way they bake the bricks is going to be different. Or is it bricks in the US?
The bricks in Sheffield used to be made with slag from the steel works. So there you might as well splan them with iron. A steel wall, not brick. It's ridiculous.
And that's why, you
wouldn't know that looking at it unless you try to drill it.
Yeah. And the problem is that people use these libraries that the vendors provide us, that it's the Bible of attenuation materials. And people like post the Ekahau slide in class. We had it that I was like brick 10 dB, drywall 3 dB. And it's like drywall half an inch or 3/4 inch, or is it drywall with wood studs or drywall with metal studs, or is it drywall with, I mean, there are so many things that, and that's just a reference, okay? Because we don't know exactly what each one of these means. It's just a number. When you go on site, then you measure. And yeah, if you have access to a site, that's great. If you don't, then you try to do your best. This is why going on site and getting samples and doing IP on stick or just doing a site visit to double check all this stuff helps a lot. Because design is just design. We're just predicting. We're just trying to figure out the best location for the access points. And that's what we do now. If I'm going to use this access point, I can just Control-C and Control-V and start moving this guy around. See? One of the very nice things that Hamina does is that as I start placing access points, notice that the channels start changing. In Ekahau, I start placing APs, and I don't know if online, Gurpreet, or you guys have been using Ekahau online lately. My account was disabled and blocked, and I'm on the shit list for Ekahau, so I don't have an account anymore. So I don't know.
It changes.
It changes? Okay. Yeah. So they're following what Hamina is doing. So
client view, Fernie, client view show downlink user experience in Hamina. How about uplink? Is that important?
Well, it can be. Let me see. Is there an uplink? I think there is an option to set up
on the right side. Where you now see worst link, you can select uplink or downlink and then select the
okay, here we go.
Okay.
Right there.
Okay.
You can check the uplink. Let's see how much it changes. So NEC 55 uplink. Did it change at all? Hang on. That
Probably
AP?
not, because by default they have 10 dB power for the AP and 10 dB power for the device, so it should be symmetrical.
Depends on the antenna of the device as well, doesn't it?
Client height, noise, minimum RSSI, client transmit power 10 dB. So many variables, man. Where do you set that? And you cannot really set the transmit power on your device. And here's the other thing. Once your battery goes down a certain level, the device start using less spatial streams, start lowering the power. The maximum power is going to be less anyway.
Power depends on the modulation.
Yes, exactly.
Yeah, let me go back to the offset quickly. For POS surveys, I truly use offsets to try to evaluate if that the offset of cell phone have good coverage. But for the predictive, I do not use offsets because basically the offset depends on the access point power. It depends on the type of client. And when I do my surveys, I usually put the power level a bit more lowered than so I use 5 or 8 dBm when I'm doing my predictives, so I can have access because they're mostly office environments, etc. I have high density amount of users, etc. So does the offset truly matters, or we can compensate this for predictive, not for post surveys?
Well, for predictive, I wouldn't bother too much with it because, I mean, you're just removing dBs off of your design. If it says in the air that should be next 60 and you go and Ekahau, for instance, you apply an offset, it removes 10 dB. So it's like, oh, if I have net 50 in the air, then a mobile device would see 10 dB less, next 60. And that's what it does. It applies that. It's the same. Some other people take the approach like, you know what? In here, I'm going to design for next 60 everywhere, not next 67, next 60. So if I say, let me just come over here and say, like, I want to see that my here, show me green where is next 60. Okay. Then it just shows, say, like, you know, that AP and next 60 is where it's green. So if you want next 60 everywhere, then you're going to need more repeats. Remember, this guy used to come like all the way out here. If I change the setting in here, I'm just adjusting where do I want my green to go. See, now I have more green. So it just, where do you apply the offset? Some guys design for a stronger value on the AP on the air because it's like, well, my devices are going to see less than that anyway. So where do you apply? You apply it here or you apply it to an offset? Because when Ekahau came out with the mobile device, like View as Mobile, we asked them, like, oh, you added that button there, View as Mobile. Yeah. Just, you know, in case you want to see the offset already applied. So like, okay, when you say mobile device, which mobile device? Well, as a smartphone. Okay, which smartphone? An Android phone, an iPhone? What type of smartphone?
Even Androids. I have an experience. I was having 2 bars in a specific location, and my friend with an Android phone, a Samsung. Mine is Motorola, and his was Samsung. So he wasn't seeing the SSID at all. So it's the same operating system. We have both 100% battery.
At WLPC in Phoenix, we did a test many years ago, that we sat at a table and put an access point sending 2.4 and 5. And then 8 meters away, we sat another table with tape and mark where we wanted people to put their phones. And we asked all the people in the audience, come put your phone, stay there for a minute, listen to 4, listen in 5. At the end of all the tests, all the iPhones, and I was talking about like iPhone 6s or something like that, if that tells you how long ago that was. Same distance, same height, same power level on the AP, same type of phones, same orientation, same. There was about a 12 dB differential between them. Same brand, and you know, iPhones are pretty, you know, consistent, and they all saw different things. So that's why when we're designing, you're going to go crazy if you're going to try to design for every device. At what height, being held how, at what power level on the device. And again, if we come to these settings over here to the client view, how are you going to adjust this? It just makes things like more complicated. Well, if the client is at 90 centimeters, what if it's at 110? Hey, Larry, good to see you here, man. I haven't seen you here before. Thanks for coming.
Yeah.
Right, Wally?
So actually, like, if we rely on like
Hey, you
mobile
know what?
device.
We should have a rule here that if you're gonna talk, you have to show us your beautiful face.
Oh, sorry. Okay, tomorrow I will make sure of that. So let's
Yeah, all
skip
right.
today. Okay,
We'll let you slip that through today.
let me have an exception today.
Go ahead.
Okay, so like I was saying, like for if we rely on like on mobile devices, like I'm designing hotels, so if I allow for mobile devices in predictive site survey, it will end up me up like over engineering, and sometimes for mobile device it becomes ridiculous. Like it show me that I need one access point, two access point per every guest room, while we usually like do it one access point maximum, like one access point in every other guest room, or sometimes one access point per room. Like if we switch to mobile devices, I will see that to have a entire coverage according to the standards, it will end up like two access point per guest room.
Yeah. And I think that, I mean, Tom, we probably only answered one of your questions so far. You start with a device in mind. Sure. And the recommendation has been like, okay, the weakest one, the least capable, most important. And yeah, that has changed over the years because we used to design for that one device. We still have to identify that device. What am I designing for? Is it a warehouse and the most important device is a barcode scanner that is an 802.11g device because they have hundreds of them and they're not going to replace them? Then we have to design for that device in mind. And then it's not only just signal strength and where do I want the waves. You just now have to start talking about the configuration of SSIDs. If the client device is a 2.4 only device, then 2.4 is going to be your main band where you have to make sure that 2.4 works everywhere. You need 5 gig and 6 gig? Sure, there are other devices. There are tablets and computers and IoT sensors. I don't know what else is there that you have to identify as well. Watch the session about the life cycle of a project, because in there we cover like the definition. We spend most of the time defining what they need Wi-Fi for, which are the client devices, who's going to be using them, when, for what. You know, is it going to be uploading stuff, downloading stuff? Is it going to be, what's going to be the quality of experience that users expect? Of course, everybody expects Wi-Fi to work everywhere for every device all the time. That's the expectation. But yes, we have to start with that device in mind because we have to modify our design. Client changes, your design changes. That's the reality of it, okay? We worry so much about the access point. My one has 4x4 and it's got 6 gig. Okay, that's good. It's important. But what's more important is what can the clients do? I mean, you don't design Wi-Fi for the APs. You design Wi-Fi for the clients. Which clients? That's why we go back to this guy. That is it the client's going to be down in the ground, you know, robots going, coming with the antennas inside this box, or is it going to be clients that are stationary or that move, but the antennas are up high? And where are the APs? Are the APs are up high or are the APs down low? Because in this place, these guys ended up putting the APs under the floor. Why? Because the clients are at ground level, at floor level. They need the waves in here. It doesn't help me to have an access point on the ceiling all the way up 15 meters in the warehouse, because those waves will have to go through the merchandise and the boxes and the robot to get to the ground and deliver waves and pick up waves from this guy. So you put the APs down low. Where are the clients going to be sitting in relation to these devices? And as a matter of fact, this is a Wi-Fi client right here. Not a human holding a device, this truck. And the antenna on this truck is all the way up here. So that's my client. How am I going to send waves to that guy? How is that guy going to send waves back to the access point? Where is the access point? Is the access point down low? Is the access point up high? Is the access point up at the top of the mine? All of these things have to be considered when we are designing. We are simulating an environment, and we are simulating the walls and the doors, and we are simulating all this stuff. And placing access points right here is just to address the coverage thing. So the access point tool, hey, this is what this session was all about. Hour and a half ago, we should be talking about it. But hey, we had great conversations. See, this is the nice thing, is that we start answering all those questions, and we have to understand all this stuff so that our design starts making more sense. If I need more access points and I need to cover this conference room too, so I come and select the access point tool. To the right, it's going to be access point. I'll be with you, Martin. You're going to select the technology because these guys can design also for like 4G or BLE. Let's talk about Wi-Fi right now. You choose the model. We had Arubas. Let's just choose a Cisco. I don't know, 9166. Could be 9120, about 9120 with internal one. Yeah, this, an Omni. These guys, let's put some Cisco's in here as well. And then in here, you define if you're going to place this access point on the ceiling or on the wall like a clock, or if you're going to be on the floor. How are you going to place it? Is it going to be on a table? Where do you want it? Let's just leave it on the ceiling at 2.5 meters from the ground. And then if you expand the show more, then you can specify the power settings for each one of the radios. Now, if I add access points, as I place this access point, it automatically starts switching the channels, and this guy is only 2.4 and 5. Notice there is no 6 gig radio. This not as 635 from Aruba that I was using before. They do have 3 radios, so it shows that. In here, if I want to place more access points and start just putting them in different places, it starts automatically doing the signal prediction and also adjusting channels to eliminate or reduce interference. Martin, go ahead.
No, I was just thinking about something I saw when you talked about the different clients. I was once in the shopping mall in our town, and there was a guy who was demonstrating a RF chamber there, which was a small size, so they could actually roll it on a trolley. And he asked people to throw in their phones in it, and he measured the quality of the LTE phones people were carrying. And he said that they also saw a lot of different results, even if they were in that chamber. And he said that a lot of modern phones actually have the same issues as Keith had with his USB sticks. They get small cracks on the motherboards, and the soldering gets small cracks when people drop it, and a lot of other things. So there is some kind of explanation, not just that the quality is not perfect along the product line, but it's also the way people have handled the devices, and we just don't know what kind of device people are.
The devices are not calibrated, even brand new out of the box. If you get 10 devices, they're going to have different readings because that's how it is.
It was an eye-opening that they were actually seeing that people were saying, my phone is so weak, and then the other one, two couple in the pair, he had exactly the same phone, and it was super good. And they tried to explain why. Okay, have you dropped it? Yes, several times. Okay.
Yes, absolutely. In this case, I added access points on the 3rd floor, and we are addressing the coverage only. Notice that you may say, oh, that's a bad area. Well, what area is it? If it's the bathrooms, do you need coverage in the bathrooms? And then some people say, oh, no, get Wi-Fi outside of the bathrooms, because then people go in the bathroom, they're going to be on the phone all the time, and it's hard to get them out of there. But then, as I just showed you in this senior care facility, bathrooms are critical. I need to make sure that I have coverage in the bathroom. Besides, unfortunately, I have designed Wi-Fi for lots and hundreds of schools here in the US. And sadly enough, here in America, we have a lot of crazies with guns. And every time there was a school shooting, I started thinking like, oh God, if that happens in one of my schools, I want to make sure that my schools have Wi-Fi everywhere. Because if there's an emergency, people hide in places that you usually would not put Wi-Fi. In the kitchen, behind, in the boiler rooms, in the bathrooms, in areas that if you ask the principals or you ask the people in charge, and then I made that mistake many times. It's like, hey, I'm going to upgrade the Wi-Fi here next summer. Where do you want Wi-Fi? Oh, man. Principals and all these people in administration, they love having meetings. So I had meetings. I have a meeting, and then they started asking, hey, Wi-Fi, who wants? And then the gym teacher said, I want Wi-Fi here and everybody. I don't want back in the locker rooms and in the bathrooms. Then people go there and stay there, and it's hard to get people. So no Wi-Fi in there. And then I was like, oh yeah, no, I read that Wi-Fi thing that gives me headaches and gives cancer. So don't put Wi-Fi in my room. Put it, in James' room next door. And then it was a big argument. People, for any reason, didn't want it. And how come he got an access point? I didn't get an access point. I've been here for 20 years, and I gave the access point to Larry, a new guy. And it's not that who gets what. It's just the design says there should be an access point here. That's where it goes. So I stopped asking those questions. And I say, you know what, Fernay, I asked myself those questions. Where do you want Wi-Fi? And I answered it like, I want Wi-Fi everywhere. Not just one signal, I want 2 signals everywhere. And I started just placing access points and Wi-Fi everywhere, okay? And then even in the boiler rooms, at the time, my guys were like, boy, why are you putting that in the, mechanical? What an idiot. You're just wasting a cable and an AP there. So I don't know, maybe one day we'll use it. Years later, all these IoT stuff started coming on board. So, we need Wi-Fi, in the boiler room for sensors and thermostats and control. Got it. You got Wi-Fi in there already? Yep. I put one in there. Put Wi-Fi everywhere. It's not that expensive when they're building the building. It's so much easier to run cables and you have the budget approved. Adding access points later, after everything is said, done, finished, budgets, allocated, E-rate, all that stuff, is really hard to get budget to add stuff. So I start adding Wi-Fi everywhere. And then in the design phase, that's what we're doing. If this is the stairs, of course, these walls here should be like brick, and there's the elevator. Most likely, see, if I change these walls, watch this. If I select these walls in here, okay? And let's say I'm going to make those concrete, which usually in these staircases, all these walls are going to be concrete anyway. So now the signals in there are not going to be that good. Yeah. It's just physics, it's waves. If you have an access point here, sends waves, those waves have to go through walls, and those walls are thick and dense, then the signal there's not going to be very good. Do you want Wi-Fi in the stairs? And if they say, no, it's just, we don't need it out there, then okay, then you can exclude this area. You go back to the scope zones, and if I draw a scope zone, let's say in this block in here, it excludes that area. Does that mean there is no Wi-Fi in there? No, there is some Wi-Fi in there. It's just that it's not showing me color-wise if the signal is good or is it bad. It's just not accounting for that area in my project, in my pass-fail rate, basically. So, yeah, go ahead.
The way I'm dealing with this is I usually plan for 2 SSIDs. One is like guest 2.4 and 5, and the other is corp 5 and 6. So for guest, we have almost the access points are almost in the maximum port level. We have just a few access points in the maximum port level. So I can cross walls, I can cross everything. And the corporate SSID, it's for based, so guest is focused on the performance, and the other is focused on guest is focused in coverage, and the other is focused in the performance. This way I can enter bathrooms, stairs, etc. So I think this is the way I sort out.
And also addressing all those devices. Like if there are 2.4 only, I ended up with clocks and lights and all those things that they didn't do 5 gig, but they were essential. So I created an SSID in 2.4 only for just those devices. Now, when adding the access point, notice I just went to the 3rd floor and did them. If I go to the 2nd floor, I'm going to have to do the same thing, start placing access points wherever I need them. But there is a tool in here. See, I can choose the access point and manually start placing them. The good thing in design is going to show me where I have access points on the floor above. See, those are these circles that show there is an access point up in that room. The recommendation, I know in some documents they talk about, oh yeah, you got this, then just copy paste to all the floors and all the APs will be in the same floor everywhere. That's a bad idea, because when you think about it, you have an access point here, and if the room above, there is another access point. They're just like 3 meters away from each other. And depending how thick the floor is, you're gonna end up with them. They don't know where they are vertically, they just hear each other. And if I hear you really strong and we are on the same channel, then I'm going to start either changing power levels, changing new channels, and then RRM may start misbehaving. So the recommendation is to stagger them. But the reality is that in a lot of places I've seen they do this because, hey, it makes sense. The bathrooms are all in the same place right above of each other. Yeah, because you have pipes and it makes sense to have the water pipes and the drains all one above the other one. Data closets. It makes sense to have them like right above each other in a building because then you just put a 4-inch hole and then you put the sleeves there and then you have direct vertical path from one room to another data room. But when it comes to access points, it's you probably want to stagger them a little bit. So the nice thing about this, if I want to start adding things manually, maybe in here, I want to place the AP in the room that is adjacent to that one, not right below, then I can stagger them and stagger them and stagger them, okay? So they're not like right on top of each other. That's one approach. It doesn't matter what you do in Wi-Fi. Somebody else is going to come and tell you like, no, Fernay, you're doing it wrong. That's not how we do it. Let me teach you the right way to do it. It's okay. You know, there will be people, they're going to have their ideas, their opinions. You need Wi-Fi in the stairs. I mean, we drew the slabs yesterday. Then we're just doing this as we go. Here's the other way you can do this. There is an auto plan. If you go to auto plan, you choose the access point. Let's say if I want to use the Aruba, the 635 model, 635, that model. Then I'm going to say I want to place this guy in 635 to 635. Here we go, and select it. Here we go. Then I'm going to specify the height. I'm going to specify the power I want to use. And here's what's going to happen. If I say start an auto plan, it completely removes everything I had done. And I think it did it. Let's see if it did it on this floor, if it did it on the other floor. I think it just did it on this floor. Let me make sure. Where are my glasses? I need my glasses. Need my eyes. For the most part, it will do the entire project, but it seems to me that it kept the access points I manually placed on the floor above. Yeah, things like this. Yeah, these guys didn't move it. So that auto plan seems like it did it only on the floor I was. Let me see if I can specify here where to do it. Usually it does the entire project, but it only did that floor. Let's see if I do an auto plan in here. Planning assistant, never from scratch, but only on this floor. I'm gonna have to ask Jerry about it. Since the area here was not defined, it even placed APs out there. And we're on the 3rd floor. They are floating out in the air. Yes, the software is smart, but not as smart as we humans. So let me just go back to the 1st floor and let's see what's happening down there. Yeah, looks like the auto planner is only doing the current floor. I wonder if I then come here and select all floors on the, no, they are all floors selected. Okay. Ekahau and Cedos, when you do auto plan, it will do the entire project, all the floors in the project. In here, evidently, it's only doing whatever floor I'm in. Okay, good to know. I'll ask Jerry and see if there is a setting. Let's see if we go to the settings for the project. Setting for the project. And let's see settings. Numbering, country, environment, project, channel settings. Numbering per AP, star, recognize numbers. I don't see a setting that says, you know, when you do an auto plan, do the entire project or do the current floor. Channel settings. This is important because here you decide which channels you're going to be using in 2.4, and you ask to disable interfering or just enable all of them, and then what channel widths are you going to be using. Now, notice that if I choose 80s, it starts with 80s, and if interference starts getting too bad, it automatically, dynamically starts going to narrower channels. So here you can do the same thing for 6 gig, define the channel width and the channels you want to be using. This is for the project. So if I go to channel settings, see here where the little I is, you can decide what you want to see or what you don't want to see. Next to it, there is a channel button that takes you to the same place of the settings for the project that you can decide which channels to use. There are some regulatory domains where certain channels are not used, or a client. Tom, going back to the client, in some places, they have clients that they're not very good with channel 165. So in that case, I'll just come and tell like, yeah, and in here, do not use channel 165. As a matter of fact, in some warehouses that I've designed lately, they do not use this Unit 2C. These devices are in Unit 1 and Unit 2 and Unit 3, but not in 165. So my channel plan, I can just leave it with this, and then it will dynamically go in and place the access points on those channels only. You just come over here. And as I place access points, you just do access points in here. I just start placing some manually. Notice that it's only, oh, this one is, yeah, in 5 gig, it's only using those channels. See, in Uni 1 and 2 and Uni 3, but not including 165. So automatically and dynamically, this will adjust. Let me do the auto plan and start on auto plan. It will remove whatever APs you have there and place new APs. When we are placing APs automatically, notice that it places some AP like, that's the entrance. I don't need an AP there. The software doesn't. Like, well, you have that as an area that you need coverage. Let me just add an AP there. And then it didn't add enough APs because this area doesn't have any APs in here, okay? So I'm going to have to come up and manually start supplementing this. So these auto planners sometimes go crazy. In ECA, how I did one building once that put like 300 access points in a place that I only needed like 7. There was a bug or something. Here in Hamina, it's done it too. I did a design with auto planner once that it plays one AP like every 1 meter, there was an access point. I mean, that would be the dream for a salesperson, huh? Like, yeah, you need 200 access points. Like, no, you don't. But in this case, the placing of access points right now, we're just doing it flat with omnidirectional ones. Given the time that we have right now, what we're going to do for now is just going to show a couple of things. And then tomorrow we're going to use directional antennas and we'll work on warehouses tomorrow, okay? Different heights, different type of antennas, different orientations, different locations. Now I have Wi-Fi selected and I'm looking at primary coverage where I have at least one signal at whatever level I need. If I'm designing for Next 65, then I set this value here. And then as let me just Control Z, as I look around wherever it's green, there is a signal of Next 67 or better. If I switch to secondary signal, what it's showing right now is where I have not just one, but 2 signals covering a place, show me green. Wherever is not green, there are not 2 signals there. And here's where some people struggle. Say, but why is that not green if there is an access point in the room? Because I'm looking at secondary signal, not just primary. Primary signal is where I have coverage. Secondary signal is where I have 2 signals covering that place in this band, in 5 gig. And it shows you right there. There's access point 38 at NEC 44. That's this guy. How do I see the AP names? If you go to the little I, you can say like, hey, show me access points and show me also the access points from adjacent floors. See right that one, say like up above, there is an access point in there. If I say, don't show me those, show me only the ones on this floor, I like to see those. But then if I want to see the channels, there they are. If I don't want to see a channel, then I don't see a channel. If I want to see a channel, if I want to see a labels, that 38, that's the AP number. If I want to see the name, access point 38, that comes in really extremely handy. We're going to see that tomorrow when we start adding names and naming convention to the access points. So let me just leave that. If I put my mouse over here, notice to the lower left, it says AP name. AP 38 is a NEC 42. So that AP in that room is a NEC 42. But the secondary signal, the second strongest signal I see is from AP 39. I don't even see AP 39 in the picture. let's see, AP39, that's that guy over there. So that guy sending waves, double distance across the power, and then it comes here. By the time it hits here, what it's telling me down there is that the second signal comes from AP39 and it's not very strong. So if I need to, now, why would I need two signals covering the same place? Redundancy. If one AP goes down, this AP goes down, then the second AP covering is too far away. There's not going to be coverage in here. So for redundancy, I need two signals. So if I need another AP covering this, what do? Well, place an AP next door, man. See, now I have two signals in here. I have the strongest one, NEC 44, coming from AP 38 right there in the room. The second strongest signal at NEC 49 comes from AP 46, which is next door. So now I'm providing two signals for redundancy. For capacity, if I have a place with lots of people, then I need two, maybe 3 or 4 signals covering the same place. To have, I know, 50 devices per radio, then you need multiple signals covering the same place. For roaming, if you have phones and you have voice in this location, then you need two signals. Why? Because if you're connected to one AP and the signal is getting weaker, what do you need for that device to be able to move to another AP? Well, you need another AP, another signal covering that place. So for roaming, you're going to need multiple signals. Redundancy for location services, you need multiple APs covering. So what the secondary signal, secondary coverage means is show me, Hamina, or Ekahau or Tesos, where in the map I have or I don't have two signals covering a place. Evidently, in this place, I don't have a secondary signal. If I switch to primary signal, this place is fine. See, there are signals in there. But if I need a second signal for redundancy or capacity or roaming, then I need more AP. So let's place another one in here. Now, I start manually filling up those gaps. If I need a secondary signal here, I don't know, maybe I place an access point here. But since I already have one in there up above, then maybe we just place the access point, I don't know, maybe out here, but depending on the construction and the place, maybe that is sufficient. If you don't need the stairs, then remove it, exclude it, or just place an access point there if you need two signals. If you still don't have two signals, then let's probably place one in here. And then that's the game. Right now, we're just providing primary and secondary coverage everywhere. Same story here. If you need more APs, then you place more APs. That's it. But that's going to cost more money. I know. But if you want redundancy everywhere, you're going to need more APs. I had that at a warehouse in the Dominican Republic. And we're going to talk about warehouses tomorrow. They said, like, yeah, we want redundancy. Then I placed two APs, one in one end of the aisle, another one at the end. And then when the proposal was sent, like, yeah, but that's too much. Okay. Yeah, remove APs. So we removed APs. But then there is no redundancy. I know. What do you want? Redundancy or cheaper project? Because you're going to have both. If you want two signals everywhere, we're going to need more APs. It's just as simple as that.
Bernard, if I'm not worried about redundancy, but I'm worried about seamless roaming, I think the way I place the access points could be a bit different, right?
Oh, absolutely, yes. Right now we're just playing with coverage. Yes, it's gonna end. That's another thing, and then we'll talk more about this when we get to designing, like in the stadium, and designing high density, because the location of the APs, when it comes to roaming and stuff and hallways, that's another place that we'll cover that tomorrow. I think with this,
no problem.
We're coming to the end. Let's see if there's any other. Tom, did we answer your second question? What was the other question? I even forgot. One was what client do you use in mind? Okay.
The second one was about roaming. So in Ekahau, it's not very eloquent on a survey, validation survey, to see how and where your client is really roaming to. You can do it, but it's not really. It could be better.
The reality is, in Wi-Fi, you cannot design where the roaming areas are. Okay, that's just not possible. In cellular, you can, right, Guillermo? You can define exactly. I want this to be my roaming area. Not in Wi-Fi. And I had this because we did a design. Well, it was not a design, it was a survey, but these people in San Jose, we were doing the city of San Jose, and we got to a point, they said, like, I want this to be a roaming area. Like, what do you mean? Like, I want that when people associate to that AP and that traffic light over there and they're walking down the sidewalk, when they get here, I want them to run to that AP on that stop sign over there. Not in Wi-Fi. It's not going to happen.
Correct. But my question, I guess, was around how do I analyze and view on an actual validation survey of a design that just went into production? How do I view how my current client was roaming through that environment on that survey?
So the best one, and we did this in Canada a couple of weeks ago at that Energy Care Center, you install.
But I guess it was relevant to Hamina. So
the
does
toolbox.
Hamina show you the different APs as you were going through that survey?
So let me show you. If you install this application, okay, the toolbox, we install the toolbox, and then once you have the toolbox installed on a computer, if you go to test network, there's a roaming log, okay? You install it and then tells you on which SSID, on which AP, on which channel and channel width and signal strength I am connected right now. As you start walking, this will tell you, oh, now I move to this other AP on this channel of this signal strength, and it will keep a log of this. Now, this is the roaming experience that I had with this computer on this walking path I did that day. Mr. Parsons posted the test we did last week or a couple of weeks ago in LinkedIn. Just yesterday, I think. Was it? Anybody following him? He posted because we did it. Him and Tom from Ubiquity and myself, we all had a computer each. We walked the same path right next to each other. We all roam differently in different places. The roaming experience of one client is not the roaming experience of the client next door. Even you can walk with two phones in your hand, you holding the same type of phone, same model. As you walk, one phone may be connected to the AP back there. The other phone may be already roamed to the AP ahead of you or to the room next door. So there is like no easy way. You can show where you roamed that day with that device in the walking path at the speed you were going. That doesn't mean anything.
And the same device can roam in different ways depending on what you are doing. So if you are doing,
if you just on standby mode, or if you're on a phone call, or if you're uploading files or downloading files or watching a video on a Zoom meeting, the device is going to make different decisions on when to roam.
Understood. So, and I've been playing with the tool. I love it, by the way. I have it on 3 of my devices. I was actually playing with it during lunch yesterday, just kind of getting more familiar with it. But I guess on the survey itself, right? So that survey of the care facility, is there a way to see how your device was roaming into what access points under what conditions?
On the survey itself, in Ekahau, you can look at the association and well, I'll show.
If you are using the Desktop Pro, you can click in the inspect, and then when you click in a place in the map, you can see to which access point you are connected.
Yeah, also, you can pop out that little second panel and you can actually see the 2 last octets of the AP you're on. But again, it's not real eloquent. So I was curious if Hamina has that same capability, if it's a little bit more eloquent or
easier to read. Easier to read instead of going and trying to figure out, oh, was that AP or was that the other AP?
Because it's not your production name. It's, you know, the octet. So then I'm cross-referencing back into Catalyst Center or something else, trying to figure out what AP I'm on.
All right, so let me see if I can find the, just look at Mr. Keith Parsons' postings from the last day or two, and there's that roaming log stuff from the wireless LAN professional toolbox. And if you don't have the tool, install it. It's really, really useful. This is just one of the many tools it has. In Hamina, let me just open a survey, because I do not think that it shows that the way we want it. If you were associated, let me go to this client view, because this is the client view of, let's see if it actually shows the actual. association, or if it just assumes. Let me ask Jerry that, because, again, active surveys, they're useless. They have no value. They just show, and I did that presentation in Phoenix earlier this year, where I showed that, this active throughput stuff, I know people ask for it, people request it. Tom, go and do an active survey. And then it's like, why? Like, well, because, active sounds better than passive, isn't it? So people think that an active survey is the way to go. No, passive survey is what we do, because active just shows you the experience you had that day with that device, given the conditions that you had at that moment when you were doing
that was probably the best point I got out of your talk, was getting that to sink in. Is like, hey, wait a second, that was that period of time. It doesn't mean an absolute across the board.
And that's the problem. Actually, watch that presentation I did earlier this year about throughput. Okay, throughput testing. And yes, we'll have another session where we cover all this stuff. But here's the main problem with this active survey stuff. See, this is exactly what you were asking for. See, throughput, where it's red, is bad. And it shows like, yeah, that's a bad location. That's a problem. We analyze active throughput data in place. Oh, room 109 is a horrible place. See, it's red. Yes, when I was there, I was getting 1.1 megabit per second. It's a horrible place. Put an AP there in room 109. But if I check the signal strength in room 109, I have one AP and NEC 18, a second and NEC 46, NEC 51. I have 5 really good burning hot access points. Room 109 is not a bad place. I just had a bad time that day I was there. We'll talk more about this later, but yes, this active throughput survey stuff, that's useless. So even if I show you where I roamed this day, so what does
Or
that
maybe
mean?
because the burst of your data, you didn't roam to a good access
Absolutely.
point. You
I
are
was
like
doing it, yeah.
stripping This is
It's
what I'm
completely useless. But people in mind, they ask you to do active surveys because, it sounds more active, more attractive. So you do an active survey. And then they want to know, they want to know the throughput of your network. Where, when, what AP was I connected to? Because one of the things I was experiencing here, the reason why I was at 1 megabit per second is because I was associated to an AP that was 34 meters away. There's America. We don't use meters in here. Okay, about 37 yards. How's that? You feel better now, Tom? Okay. 37 yards away. Going through 1, 2, 3, 4, 5 walls and doors and peoples and bookshelves and stuff. This is a school. You're associated to an AP that is 37 yards away. Yeah, I had a bad day. Not a bad place. But my device didn't roam. And even if I show you where I roam, what does that mean? That doesn't mean everybody's going to roam right there. It just means that that day with that device, depending on what I was doing and the IP where I was, that's where I roam. Completely useless. All right. With this, my friends, we come to the end of session 366 of Tesos and Wi-Fi. These sessions get really interesting. See, our plan was just like, hey, I'll show you how to place APs on a map. And then 2 hours later, we have not covered that much, but we cover many other really important things. That's the best part of this class, see? And we talk about Ekahau and Hamina and Tesos, and we're going to be covering all of those later because we're not in a hurry. We don't have a schedule to meet or an agenda to go through and like, oh no, sorry, Glenn, we cannot talk about that now. That's another product. I cannot mention any other products. I'm here to just talk about one product. No, talking about Wi-Fi. That's what we're doing. So have a beautiful rest of the day wherever in the world you are. Thanks for coming. Today we talked about many things, including, placing APs. Tomorrow we'll continue about just like today we look at covering primary signals and secondary signals in the in a design and why would we need those. We talk about client devices, what type of device are we going to design for, the importance of having all of the things in the design, tables, chairs, racks, all that stuff, because now the signal prediction is not only horizontally, but also vertically from floor to floor. So watch this later. We're going to be uploading this later today. I really appreciate your time. Just now, you know it, free love for everyone and free Wi-Fi training for everybody. Have a great rest of the day. I'll see you tomorrow. We'll talk about
Gracias, señor.
Thank you so much.
Thanks,
Have a beautiful day.
See you tomorrow. Bye.
Thank you. If I didn't answer your questions today, just remind me of those tomorrow. Oh, here, Elaine posted the posting about Mr. Parsons' tests from the client radio app. This is the 3 roaming devices, SSIDs, associate, complete, receive an IP address. I think this is the process of, let's see, checking the client MCS. Great posting. It's going to be on the notes anyway. And then I'll try to find the one where it shows the roaming log. Remember, if you don't have the WLANPros toolbox, install it. It's free. It runs on Windows, Mac, iOS, Android, everything. So add it to your toolbox, and that's going to make your toolbox more complete. Hey, have a good one, man. Take care.